Welcome to the session where we are trying to understand more about what is Hadoop distributed file system. So, we have seen a lot of things pertaining to Hdfs. Now, we will try to understand some more valuable insights about Hadoop distributed file system. So, when do we have to use this Hadoop distributed file system is the question. When do I need a Hadoop distributed file system? So, because I have been doing well with the already existing architecture, analytical architecture, all the file systems, but why do I need Hdfs? Why do I need Hadoop distributed file system? So, when a data set outgrows the storage capacity of a single physical machine, when my data outgrows where I cannot actually store it or cannot process it, or when it becomes beyond the processing capacity of my existing architecture, then I need a better place where I can store is called as Hdfs. So, when my storage capacity of a single machine outgrows, so it becomes necessary to partition it across the separate machines. So, what happens is, if I partition it, if I distribute it, then it becomes very easy for me to process. So, there should be a file system which actually does this. Any file system that manages the storage across a network of machines is called as distributed file system. So, any file system which actually manages all these breaking of the data or distributing of the data across the network, it is called as distributed file system. Now, here Hadoop comes with a distributed file system called Hdfs. Hadoop comes with a distributed file system called as Hdfs. Now, Hdfs stands for Hadoop distributed file system. So, nowadays, as we have seen, there is so much of digital data out there, and now in order to do some analysis on my data which is keep on growing, I need a different file system where I can handle this, because all the organizations either if their data outgrows their existing capacity, two things they can do: either they can delete the existing data and store the new coming data, or they can buy a new infrastructure, So, out of these two are not good for a company, because every time when I see my data growing, I simply cannot go and buy some new infrastructure. So, which is not good idea. So, to avoid all these things, I have a wonderful file system called as Hdfs. So, in Hdfs, I know what is Hadoop. Hadoop is a data framework, or Hadoop is a framework which deals with big data, or Hadoop can also be called as data operating system. So, I know what is a distributed file system now. So, in a combination, I have Hadoop distributed file system. So, now let us understand the design of Hadoop distributed file system. What are the different advantages that I have when it comes to Hadoop distributed file system? The major advantages are Hadoop can deal with very large files. And the second point is streaming data access. So, now we'll understand what is streaming data access, and the third one is commodity hardware. So, Hadoop or Hdfs is designed in such a way that it can deal with very large files. There is a concept of streaming data access, and Hadoop can be run on commodity hardware. So, we'll try to understand one after the other. Very large files. So, very large in this context means files that are hundreds of megabytes, gigabytes, or terabytes. So, you can also add petabytes as well. So, there are Hadoop clusters running today that stores petabytes of data. Yes, for example, Facebook, for example, Yahoo, for example, any astronomical websites, for example, any matrimonial websites, all these websites, or any data which is pertaining to stock exchange or airline data. Any firm, if you take, there are Hadoop clusters running today that stores petabytes of data. So, when I say big data, when I say large amount of data, so it can be any data which is above terabytes or petabytes of data. Now, what is this streaming data access? So, Hadoop is designed in such a way, Hadoop or HDFS is designed in such a way that it can deal with large amounts of data, Now, what is this streaming data access? Streaming data access implies that instead of reading data as packets or chunks, data is read continuously. This is very important. So, here when it comes to HDFS, it will read the data continuously. No matter how much the data that you wanted to dump in, I don't say no. I keep on taking the data and I'll keep on reading the data continuously. So, streaming data, it comes as a flow. It comes as a stream, it comes as a flow. So, no matter how much flow that you wanted to store on HDFS, so HDFS is designed for streaming data access. Again, streaming data access can also be quote one more example, when you are no matter how many videos that you wanted to do, no matter how many text files that you wanted to upload, no matter how many image files that you wanted to upload, HDFS will not say no, because it works on a concept of streaming data access. So, streaming data access implies that instead of reading data as packets or chunks, data is read continuously with a constant flow, just as water from a tap. So, this is very important. So, not only that, the application starts reading data from the start of a file and keeps on reading it in a sequential manner without random seeks. HDFS is designed on a processing pattern called write once, read many times. HDFS is designed on a processing pattern called write once, read many times. This is very important. Write once, read many times. That means you can only write the data on HDFS only once. The once you write the data, you cannot do anything. Though you can read many times, but you cannot modify the data, you cannot upload the data, you cannot append the data. Again, there are certain versions of Hadoop, which actually support the concept of appending, and also there are certain modules or subcomponents under Hadoop ecosystem which also support the concept of update when it comes to updating the data. But on the whole, HDFS is designed on a pattern of write once and read many times. Write once and read many times. Not only that, the application starts reading data from start of a file and keeps on reading it without random seeks. That is streaming data access. And the very important, the third property what HDFS has is it can be run, it can be installed on a commodity hardware. When I say commodity hardware, the existing hardware in any of the companies. As we have been saying, Hadoop is what are the little systems that you have with the minimum configuration. We don't have to worry about it, because Hadoop can be downloaded on commodity hardware. So, existing infrastructure, no matter how old my systems are, if they meet the certain prerequisites, if I wanted to install HDFS, I don't have to buy any other new hardware. I can install my HDFS on my commodity. So, you have to remember the word commodity. Commodity is the existing, you every day the commodity that we have been using. So, Hadoop does not require expensive, highly reliable hardware to run. It is designed to run on a cluster of commodity hardware, commonly available hardware from multiple vendors. So, here again there is a condition. So, when I say commodity doesn't require expensive, it is not for the entire cluster. Again, when we talk about the Hadoop architecture, HDFS architecture, then we would be talking about the name node, secondary name node, and the job tracker. So, these three we'll keep only the expansive, the advanced systems, but rest of the cluster can have the inexpensive, or rest of the cluster can have inexpensive expensive commodity. So remember this, though we can install it on a commodity hardware, but what we'll see is this name node and the secondary name node. So all these terminals are pertaining to Hadoop. We'll understand and study when we are dealing with Hadoop distributed file system. So so here now what happens is, when you are using the commodity hardware, there is a chance where you may lose data. There can be a node failure. So in which the chance of node failure across the cluster is high. So for the very big large clusters, yes, there is a chance of the node failure, but HDFS is designed to carry on working without a noticeable interruption to the user. So in the case of such failures, so no matter, so that is the beauty of HDFS. So I have one node being on a cluster, one node being failed, but HDFS is designed in such a way that it is not, we cannot see any noticeable interruption to the user. So if any node gets failed, no matter, you don't have to stop the work immediately. There is certain things which will be taken care by the HDFS or Hadoop distributed file. So HDFS is designed to carry on working without a noticeable interruption to the user. So that is these are the three characteristics of HDFS. So very large files and streaming data access, where you can continuously read the data, and it runs on a processing pattern called write once and read many times, and it can be installed on commodity hardware. So this is how HDFS is designed. Why do I need an HDFS? Because when my current file system cannot hold the growing data of a company, so it has got distributed file system, so Hadoop distributed file system. So what are the advantages? of HDFS? So HDFS can be dealt with very large amount of data, and it has a concept of streaming data access and commodity hardware. So when we talk about write once, read many times, so a lot of things involved in this line. So you just now Hadoop or HDFS can also be called as OLAP, online analytical processing, not OLTP. So again, if you wanted to make it an OLAP, we have certain things under Hadoop ecosystem which we would be dealing with. So on the whole, remember, Hadoop runs on a processing pattern called write once and read many times, and it can be run on a commodity hardware. If you have any node failure as well, that Hadoop takes care of that and will not interrupt the user, or it will not make a user to notice that. So these are the things that we have to remember when it comes to HDFS. So HDFS stands for Hadoop distributed file system. Now what is Hadoop? What is Hadoop? The next slide will be talking about what is Hadoop. So just to understand what is Hadoop, it's a framework. Hadoop is a framework which allows distributed processing of large sets of data across clusters, and these clusters can be on commodity hardware, and the whole Hadoop is written using a simple programming model written in Java. So Hadoop is a framework that allows distributed processing of large sets of data across the clusters of commodity hardware using a simple programming model written in Java. So Hadoop is open source data management system, or open source data management with scale out and distributed processing. So it is something like a tool. it is something like a tool. So for example, I have a toolbox and in which I have screwdriver, I have a spanner, I have a cutting plier, I have so all these cutting pliers. So anything I want, I can have that on that particular tool. The reason why we are calling Hadoop as a toolbox is because any form of data, any problem pertaining to analyzing any form of data, yes, Hadoop is the answer. Hadoop is the answer. So the key characteristics of Hadoop. Now let us talk about the key characteristics of Hadoop. Now Hadoop is reliable. Hadoop is reliable. Yes, Hadoop is very much reliable. No matter how much data that you wanted to dump in, or no matter which form of data that you wanted to deal with, Hadoop or Hdfs is the answer. It is very economical. The reason being, it can be installed on the commodity hardware. That can be installed on the commodity hardware, and it's open source as well. It is open source. Now scalability is, it can be installed on any number of nodes on a cluster. Either it can be 3000 node cluster, it can be a 100 node cluster, or it can be a 10 node cluster. The scalability of the data is very much there in Hadoop, and it is also very flexible in a way. Again, it can be read, it can be stored. Not only the storage, we also can do some processing. So these are the key characteristics of Hadoop. So Hadoop is reliable, Hadoop is economical, Hadoop is scalable, and Hadoop is also flexible. So Hadoop on the whole, Apache Hadoop is a framework which allows the distributed processing. Now why we are calling it as a framework, and who actually gave the name Hadoop to this particular framework, who actually invented, what is the history of Hadoop, all these things we will be looking at and trying to understand in the coming sections. Thank you. Have a good day.